All right, in question 2, we're asked to solve these following systems using the method of substitution. Okay, so the idea here is to isolate one of the variables if that's not already the case. And in here, we don't have any of the variables isolated. So what I mean by that is an equation of the form, say, y is equal to blah, 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 or z is equal to da, 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 da. Okay, so what I could do to start out here is say solve for y in equation 3. Okay, so I can do that by just subtracting z from both sides. And so this tells us that y is equal to 1 minus z. Okay, and now in equation 1, I have 2x plus y is equal to 5. And so if I substitute in, hence the name substitution, this expression for y, this will give me an equation that involves x and z. Okay, so this will give us 2x plus, and then y, which is 1 minus z, and that's equal to 5. Okay, now I also have this equation, right? Equation 2 that only involves x and z. So now with these two equations, right, the modified equation 1 and equation 2, they only involve x and z. So then I can go ahead and solve that system either using a similar kind of substitution method, or I could even use elimination at this point. Okay, so let's go ahead and carry each of these through here. So what I'm going to do is first just clean up equation 1. So I have 2x minus z, and then for the 1 here, I'm going to subtract the 1 from both sides, and that's going to give me a 4 over on the right side. And then I'm just going to copy equation 2. So this is 2x plus z is equal to 2. And so note here that the z terms are equal but opposite. So I'm just going to go ahead and add. And the z's will drop out, and I get a 4x on the left and a 6 on the right. And so now dividing both sides by 4 tells us that x is equal to 3 over 2, or 1.5. All right, so not too bad. And so then how about x? Oh, sorry, z. Well, to find z, let's just go ahead and plug 3/2 into either this equation or this equation, doesn't really matter. I'll go ahead and use the top one. So for z here, okay, if I use the top one, I have 2 times x minus z is equal to 4. And x I now know is 3 over 2. And 2 times 3/2, these 2's cancel out, so I just get a 3 minus a z is equal to 4. So subtract 3 from both sides. 4 minus 3 is 1. Divide both sides by -1, and we get that z is -1. Okay, and so now we just need to find y. And for that, right, we know that y is equal to 1 minus z. So here I can say that y is equal to 1 minus z, which is -1. So be careful there with your signs. 1 minus a -1 is a +2. All right, so then for our final answer here, we'll write this as an ordered triple, just like we were doing in the last video. So this is 3/2 for x, 2 for y, and -1 for z. Cool. All right, so that is our solution. Let's go ahead and do part B. And you may want to pause the video and just work through this on your own just to check. But I'll go ahead and start this now. So here, let's choose a variable first to isolate, because again, like part A, we don't have any of the variables isolated. And I notice in equation 2, if I just subtract 3w from both sides, then I can easily isolate u. So u would be minus 3w. And note here, I could isolate, say, w in equation 3 without much trouble. The downside there, though, is if you divide by 2, then you're going to have some fractions. So would work, it's just maybe a little bit on the messier side. Okay, so now what can I do with the fact that u is equal to negative 3w? Well, I could plug that into equation 1. So in other words, substitute minus 3w in for u. So this would look like the following. I have minus 3w and then plus v plus w is equal to 2. Okay, so this is an equation that involves only v and w, and then I could likewise substitute in minus 3w in for u in equation 3. So that's going to look like this. 2w is equal to 7 plus u, so I'm going to write this as plus a minus 3w, so it's really just subtracting 3w, and then we're adding v to that. Okay, so now these two equations, right, the modified equation 1 and the modified equation 3, they just involve w and v, and so let's go ahead and clean them up and then solve that resulting system. Okay, so here I will get what? Well, I have a v and then minus 3w plus w. That is minus 2w, and that's equal to 2. And then for this equation down here, well, I could go ahead and add the 3w and then subtract the v. And so if I did that, I would get a minus v on the left. And then for the w's, I'm going to have 2w plus 3w, so that'd be plus 5w. And then I'm just going to leave this 7 over there on the right side. Okay, now notice for this resulting system, the v's are equal but opposite. So if I go ahead and add now, they're going to drop out, and I'm going to wind up with 3w here. And then on the right, 2 and 7 is 9. All right, so this gives us the value of w, which is nice. W is 3. And now we just sort of unpack from here, right? So if w is 3, how can I go about finding v? Well, I can use either this equation in blue or this equation here in red. I'll go ahead and use the equation in blue. So for v here, we can use the fact that v minus 2 times w, which is equal to 3, is equal to all equal to 2 there. So v minus 6 is equal to 2, and then add 6 to both sides. So we get that v is equal to 8. All right, and then lastly, we just have u to solve for. And for that, we can use the fact that u is minus 3w. So u is equal to minus 3 times w, and w we know is 3. So this tells us that u is equal to negative 9. All right. So then again, we'll just put that all together as an ordered triple. So u is negative 9. V is equal to 8. And then w is equal to 3. And that will do it. All right. Thank you so much.